Okay. Hello? Okay, so that sounds good. And then we need this turned on. Set my drink down. Got my snack. Skip whatever this is. Okay. Alright. I think we're ready to go. Let me just change what we're working on. Alright, we're gonna go. Okay, so what are we gonna work on? A-star pathfinding is the answer. Oops. Here we go. Like I said, I've coded this before, so this should be hopefully easy. Leave me alone. 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 Sorry. Okay. Oops. Alright, here we go. So, before I look up more about A-star, because I don't... Let me just do as much as I can remember. Oh, Jesus. This is a terrible grid. Terrible grid. Terrible grid. Alright, that's it. There we go. That looks good. Okay, so you have a start position right here, and then you have a goal. And then you check your cell right here, and then your cell right here, and then you have your H, F, and like some other thing cost. And then you pick the one with the lowest F, and then you explore that one. Check this, figure out the one with the lowest F, and then you travel. And then you have to trace back. And then you point to where you explored. And then you can trace back. And then there you go. And then you follow the arrows backwards. Alright, I think I'm ready. Let's do go. So we're gonna put this in its own little section because this is only gonna be for the monster. Pathfinding. Yeah, whatever. There you go. Okay. There you go. Okay, so we're gonna need a copy of the world, right? So we're gonna need to include map, and I just know what we are, right? Because we're gonna need to explore cells. So there we go. The H, the G, and the F. Okay, I don't care, bro. Just give me it. You're stupid. Okay. So for our pathfinding, right now we're just gonna have a struct called a cell, and we'll just have right now it's float FGH. Now that's what we're just gonna have. There you go. Then what else? F is the total cost of node. G is this. Oh, what's up? Yes. Alright, we're gonna code pathfinding finally, like I said for the last 2 streams, but today we're actually gonna do it. Because we got done with everything else. Okay. So G is distance from current pause to start. H is distance from current pause to end. And F is G plus H. There you go. So now we're also going to have to include an X and a Y for our current position. don't like this. It's a bit annoying me. Okay. So alright, so here's how okay. I need to think about how we're gonna actually implement this into the game. Because we're gonna have our grid, and then we'll have, oh Jesus, I'll just make it look like that. So this will be our goal, this will be our start. So we'll start from here, and then we'll have an array of just explored cells. So like this one and this one. Then we calculate, so okay, so we're gonna need access to the maps position. So here we go. Let's do just make it simple to avoid. So let's make this called, I would say this is cell, and then we just have struct called path, which holds, oh, I cannot spell, a vector of cells. Path, right? Cells. And then we need to have a flag of, no, that's okay. So here, I have to pass in a void called step, which takes in a path, and then I'll take in a vector of our vec2fs called map or a grid. I'll just call this cells. No, that's too many words. I'll just do matrix. No, map. Yeah. Okay. Whatever. Just do that one. So now, here's what's gonna happen, and then we're gonna need our current cell called cur. There you go. So what's gonna happen is say we're right here, but we need to search this cell, and this cell. So this is what needs to happen. So we need to check we need to go first up, then to the right, then to the left, and then down, and then explore those cells, and then we pick the lowest F cost, and then add, and then count that one as explored. Right? And then that result in it being explored. Okay, so we're gonna need a open list and a closed one. And what's gonna happen here is the first thing we're gonna do is from our current position, we're gonna do p open dot pushback. We're gonna have to push back the top. Oh my god. We're gonna have to push back the top and then one below it to the left and to the right. So push back map or oh, I don't have map included here. I'm just include it here. Include map map slash map. So map get block. Oh, I have to pass in the actual map. Oh my god. So here we go. There you go. Now, so watch you just pass in the map. And then what we say is m, and then we say cur.x plus 1. Oh, wait, no, because we want to go, this one's up, so cur.x or y minus 1. I think that'll get us started. And then push back its position. What's wrong with you? Oh, well, I need to push back a cell. Okay. There we go. And then we just change this to K, and then just push back. Just did the rest blank. This is gonna be cur.pause.x, and then now this is gonna be cur.pause.y. So here's a problem, is that this is not going to be in the format that we need to actually grab this from, right? So we're going to have to divide this by 64. And that should translate correctly. And then instead of printing all this out right now, I just want to run this check to see what happens. And then we'll just there you go. And then let's go. Let's see if I even can compile. Okay. So let's make this map smaller. Where is it? Okay. 4, 4. Let's do 5 by 5. Goodbye. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. Wait, is that 1, 2, 3, 4, 5? No. Okay. Then we're at 3, 4, 5. And then put the player. Okay. So now this is our new map, and what we're gonna do is our starting cell. This is gonna be our starting cell. And then we're going to go and grab this where basically this is going to be our starting, this is going to be our end, but right now we're just going to see if our algorithm will grab this. So to see what I'm going to do to actually test this, so I'm going to open up Paint and make new textures so that I can change these textures. Go, and then the orange will be explored cells. I never started my work timer. Oh my god, I love that timer and I just forgot it. Alright, now I'm complete. Okay. And this will be, I need to say this as a JPEG. Looked, and then the red will be saved as closed, and then this will be saved as like path. Now, you load up looks, and then we'll do closed, and then we'll do path. So that would be 0, 1, 2, 3, 4. And then now when I go into my map, I need to make it so I can change I can actually set data. So I need to go here and then say, just for testing, void blah our map change texture, and then pass in oh wait, we need a point. Now we need a pointer. Okay. Then do this calculation. And then we'll do, and we need to have the texture ID that we need. And then we'll set here, and then we'll say map at texture IDs at I is equal to texture index. And then let's see what happens. And then break, and now we're gonna do, alright, so this, I'm gonna change, let's see, okay. I'm gonna change the top red, left texture, change texture, map. We're gonna change it to 2 at 0, 0. There you go. There you go. Now we can change textures on the fly. And then I'm gonna need to pass in, I wanna make, here. I'm gonna make a offset here, and then a tool called adjusted. There you go. Adjusted. And then if not adjusted, x is going to equal x minus x modulus 64, and y is going to equal y minus. Oh wait, you know what? There you go. There you go. So now we do that, and then divide it by 64. And we should still get the same one. So now map, change texture, do 2 at 0, 0, adjusted, we are not adjusted. There you go. Okay, so it grabs it, and then if we say that we're not adjusted and we set it at like 16 and 31, we should be set in the right spot. Still. Yes, we are. Alright, so what happened there is what I'm doing there is I'm sick of having to do this calculation every single time. Because I keep forgetting whether or not I'm adjusted. Because what's happening is our grid is laid out like this. So this is how our map is. This is how the map actually works. So we have 0, 1, and then 0, 1. And when I'm doing, but each of these coordinates in like the game sense has 64 and 64 here. So change in x is equal to 64, and then change in y. Oops, that was a bad triangle. Is equal to 64. So the problem is I have to always calculate and adjust back down to this matrix right here in order to grab the right cell data. And I'm sick of doing that, so I'm just gonna make a function. I just added a part to this function where I can pass in whether or not we adjust it or not, and then it'll automatically adjust to the matrix for me. So if I can, so like if I have my player position, if my player's right here and he's like in this cell, we can automatically tell what cell he's in because this function will take his coordinates, which here would be like 120, like 32 maybe, and then it'll adjust it to the correct spot, which would be right here, and then divide it, and then it'll grab 1, and then it would grab 0, 1 for me. So if I were to do, so what should happen is, every time I move the player, we're gonna set the tile under it. We're gonna set the tile under the player, like orange. So this should work, hopefully. And I did not just make myself look like a clown. And then there you go. It's automatically adjusted. Well, I never set it back, but so I'm right here. Boom, boom, boom. There you go. And there you go. But if I were to set this to true, I'm gonna crash. Because we're gonna get a vector out of subscript range thingy. Oh, or it's just not gonna do anything. Which, good thing it didn't crash. But yeah, so that's why I just did that. And I will add that check to my other thing. My other load function right here. Oh, not this. I don't care about that. I care about this one. Where am I? Oh, here we go. And just take that. There you go. So now we automatically adjust. So I need to grab my laptop real quick and grab up the coded example I have of my pathfinding algorithm, so I can remember what I'm doing. Quick overview of the algorithm for what I remember is, I'm pretty sure I've done this like 30 times. I already explained this, but I'm gonna explain it again. Just draw a grid, okay, I don't care. This is our goal, this is our start. We search, like this way. We search like that. We'll search this cell, then we'll look at the 4 cells, pick the one with the lowest F value, which is the distance from the goal cell and the distance from the start cell added up, and which would probably be this one. And then we pick that one, and then put that into an array of explored cells. Then do the same thing there, so ding, 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 but make sure we don't include the start cell. Pick the lowest one would probably be this one. Go over there, put that into explored cells, and then make sure you point to where you go, by the way. And then this would do the same thing. It would probably pick either one of these two, but we'll just pick this one. And then it would go, and then you point there, and then it sees that this is a goal cell, and then we'll point there. And then once you hit the goal cell, you have to walk back where it came from. So you just would reverse this pointer right here. Oh my god, wait. That'd be genius of me if I did that. If I made this into a linked list? No. No, that's stupid. I think that's stupid. That'd be cool. That'd be a good thing to brag about if I made that into a linked list. I got you, say I use data structures. Just think about it. Think about it. Alright, this is blocked off. You explore this. These both get explored. But they start from the start cell. Wait a minute. No, that's stupid. I think that's stupid. Because that doesn't make sense. Because then the start cell is pointing to 2 things, so can't do that in a linked list. It has to be linear. Unless for the start cell. Nah, I'm overcomplicating it. Don't do that. That's a bad idea. Alright, one second. I have to pull. Oh, did I ever add this? Yes, I need to pull up my old project, and I also need to find these errors from me doing the adjusted thing. Here it is. It's broken. Oh, don't do that. Here we go. It is adjusted. 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 This is also adjusted. Oh, wait. And this is adjusted, and this is adjusted. Yeah, alright, now we're chilling. Okay. Okay, so now time to see how I did this back in my other thing. Let me load this up and see what it looked like. Okay. Okay. Pathfinding. Here we go. All right. Okay. So, Pathfinding. This will be called node, not cell anymore. I don't like that name. This will just be called n. Actually, no. This will be called curve. And then node. Okay. So this will be called a star. And what we will have. Why are you giving me issues? Oh. I'll just call it. There you go. Now we will have this, and then we need to store our start cell and our end. Then I don't know why I did that. We need to find a max amount of steps. Find max steps is equal to 100 right now. So we don't crash our program when we, go out of it. Then in our node, we're gonna store our position, and then we're gonna store our parent position. Okay. And these can be changed to ints because they don't really need to be anything else. Oh wait, no. Int x, int y, int parent y, and int parent. Well, you know what? Int xy, int parent x, int parents y. Then we'll do those floats, and then we'll have a boolean at the end to check if we are collapsed. Spell that wrong. Collapsed. There you go. Then in our algorithm, we store our start and our end. And then we need to store a vector of nodes called open, and then a vector of nodes called close. So the first thing we can do is we need to create our algorithm. A star pathfinding init, and then you pass an A star. Alg, and then you pass in your node called S and your node called start and your node called goal. Then alg dot start is equal to start, and alg end is equal to end, or it's equal to goal. And this needs to be turned to goal. Okay. So now that we have that, our actual monster is the only thing that's gonna need the algorithm, but right now, we're only going to just compare. We're gonna just go in a straight line for now, or we're gonna go kind of directly across. So let me do this. Nah, that's fine. So we're gonna start at the player's position. So in our main.cpp, we're gonna do this test. So testing A star. So I need to include Pathfinding. And then our start will be, we're gonna store the correct, actually X and Y, so player, we're gonna need to do node player.pause.x and then player.pause.y. And then our goal is going to be the upper cell, which is going to be, what, 0, I'll just count right here, oh wait. Zero, 64, 128, 1, 2, 3, 4. 4 times 64 is 256. 256, that's 64. There you go. And then as soon as we init everything, we're just gonna want to do map dot change texture. That's it. This is going to a global variable. Go. Okay, so because I'm sick of doing all that stuff. It's annoying me. I'm sick of grabbing it. I'm sick of having to. I'm done. I'm done, okay? So I don't want any longer function parameters. It's making me mad. So we can just do map, change texture. We're gonna do never had. I guess we'll just do for goal.x, goal.y, and just let this fall. Alright, so that should change. Oops, I did my math wrong. Zero, 64, 128. It's 192. There you go, and then we can set exact same thing, but then we'll do what? 3 for the start. Yeah, so now those are our start and our end. And then, that's all we need so far. Now what we need to do is look up and down. So right now we're gonna only look up. Here, let me do this. Let's just increase this to 10. There we go. Then, now here's the first step. Now we need to do the check. So the first thing we're gonna do is check up. Basically what we need to do is alg dot. So we'll do what I do here. Okay. And then we'll do pathfinding check dr. That's in our algorithm. And then this will return what I do here. I did check direction, find where we needed to go. Okay, so I guess we can just pass in that, and then our int x and our int y that we need to check, right? Or, well, we need to pass in our origin node, and then we need to pass in int x and int y. So what's gonna happen here? Here, what we're gonna do is actually, instead of just passing in the, well, we need to pass in that anyways, but I don't really want to pass in a pointer. We will just return, no, because, yeah, no, actually, let's just try doing it. So what's gonna happen here is if we get a valid node, we're gonna be good and we won't return null, but for now, we're gonna return null. Do that? Are you serious? Never mind. Well, all we need is just to shove these things into a vector of our nodes, which would be called open. Well, we need our map. That's the problem, right? So we need our tiles, first of all. Wait, no. No, we don't. No, we don't. Open. Open. So we pass in that, right? What's gonna happen here? Is we're gonna do, and we're gonna need to make a function called these calculate functions. Whatever, we can calculate. Okay. Utils inline flow calculate hypo. And called A and called B, and then and then return 8. Return the square roots of POW of A to 2 plus POW of B to 2. And then in here, include utils. Oh, there should be a math. There should be math. There should be its own thing. So I should make Is there already like a math? I don't want to like. There is. I don't want to do that. I just name it U underscore math. And then we can shove all this we can just shove all this into our math. And then, now that that's in like a nice math folder, we gotta just run through all these errors real quick and get those out of the way. This needs to be changed to what? You need umath, right? Natural utils, there you go. This needs utils dash math. And then this also needs regular utils. There we go. Alright, now that I just finished doing all that, we can go back to here. And then we have our calculate hypo, so include math or util. until start underscore math. And then when we check the direction, first of all, I just want to print f that should be 5 or something, or some weird what's a I forgot how triangles work. Oh wait, this needs to be an F. And a perfect triangle would be like a squared plus b squared. Wait, what's like a perfect triangle? Okay. All right. Six and 8, so that should equal 10. Right? 3, let's do 3 and 4. That should equal 5. Yeah, so that's right. And then I need to also change this to math. That's gonna cause a lot of errors. I'll do that later. I don't care. Okay, so remember, now we need to, when we check a direction, I don't even think we need this to be open. This could just be its own little thing here, because we never actually would call that from a separate file. Let me see how my entity uses it. Oh my god, this code is so bad. I never made its own entity file. I put it all in a header. What is wrong with me? Jesus, bro. What the hell? Sorry, what is this? What did I write, dude? I wrote this like 4 months ago, but I didn't realize I was that stupid. I can't even like read that. That's terrible. Whatever. For now, I'm just gonna shove this in here. Actually, no, I'm gonna put this out of the bunch because I actually need to call this. So we need to check this first cell, just up. So what we'll do is we'll create a node called n is equal to this information. First of all, we're gonna need an x and a y, and then its parent. So where did it come from? Which is our origin. So node dash n, and then we need a block called b, which is equal to map get block, and then we'll do global get map, and then we'll do x divided by 64 y divided by 64, and then we'll do plus x. One check, one up. And then we're gonna go main. Oh wait, well, if you add one, we're going down again. So this needs to be, this is actually looking down. So this needs to be negative as well with upward. Then go into main. Call this pathfinding step. Pass in our pathfinding. Okay, here's the thing. Now I'm questioning whether I wanted to have that global map in there. Let me think about it. Because I really could just pass it in everywhere, but it's so annoying. Oh. You know what? Why not his A-star? We just keep a reference to our map. I always want to keep a copy of it. go. That's all that's all. And the current would be pathfinding dot sticker. And what we should do is, for now, just for debug purposes, change its color to looked at, which is 2. Just do that. There we go. And now we can just call this. Boom, boom, boom. Now check below, check to the right, and check to the left. And now, there you go. And now what we need to do is actually just put this into a node. So node dot, first of all, collapse the equal false. Here. And we can create a nice little function called void init node. And so node x what is this? There you go, because that's annoying me to set that up every time. Then, way to do is pass back this. Just init node, taking that, and we'll do b.pause.x, b.pause.y. For now, this will be org.pause, org.x, org.y, 0, 0, 0, and then false. Okay. Open.pushback, and here's a problem. That actually might go out of memory. So let me put a breakpoint here and see what happens. Because now that I'm thinking about it, that might actually, because we're creating this here, initializing it, and that gets deleted after we exit out of the function, unless we push back that data and then save it. Well, the breakpoint was never reached. The fuck? Oh, because I'm in release mode. Oopsie. Oh, what is that, dude? Alright, and now let's look at open, and there's 4, and they all have data stored. Okay, good. So let's copy it over. Good. Good, good, good. So now that's all. Now all that data is stored. So now we have the initial thing of checking the 4. Then we need to pick the one with the lowest up cost. So first of all, we need to calculate all the costs now. So let's do that. Float called G cost, which is equal to G is one second, I'm watching this algorithm. Okay, this is interesting to me. And then so G is current node and start node. And to find that, we need to first, so what's gonna happen if we're talking about this one right here? Well, its distance would be 32, technically, right? Because we're going here to here. Because this will be 32, and then you have the height is 32 away, and then this is 64 away, technically. So 64. How are we gonna, now we need, wait, whoa. So we could technically just take the triangle. Because if we had this, and then this, and this is the cell we're looking at, we need, and this is our positions. We need to take the triangle between that, so that'd be here and here. So it would be the triangle. Because we think of the triangle. S dot x minus G dot x. So if this is at 32 and this is at 64, then you get that's your x. And then you just minus the height, which would be S dot y minus G dot y, which this would be now 0. So because this would be like 32 and this would be 32. So then you get 3 squared is equal to 0 squared plus 0 squared is 9, which is equal to 3. So the distance, wait, what? No, this is 32. What am I doing? And then so it would just be equal to 32, and then that's okay. There we go. So G is equal to calculate hypo of our origin point x minus our current, which would be, and then our origin dot y minus our current dot y, and then pass that in as our G. FGH, because this is distance from start to current. Flow H, distance from n to current, or current to n, and then flow F is equal to G plus H. We can just do F now, and then we do H. FGH, and then this will be calculate hypo from B dot pos dot x minus our goal. Pass on a goal cell now. And that would be alg at goal. There you go. And then goal dot x, and then b dot pos dot y minus goal dot y. There you go. So you would have that, and then you assign that, and then there we go. So now let's check it. So we want to check, for now, I'm just going to do the one to the right, which is that one. So it should just be 32. F should just equal 32, and then put a breakpoint right there. Go. And then f dot open holds this, and the f is very, very, oh well, yeah, so 64. B dot pause. Well, isn't origin? Origin should be. Do I even have it? Can I even see it? I guess not. So I'm not. Wait. The breakpoint here. There you go. So we have origin, which is at 256. Whoa. That's not right. And that's why. That's what I say, dude. It should be start and then goal. It should not just be goal and then origin. It should be this. And then your origin. There you go. Now it should be right. Um, 64 again. B dot pauses. Around 800, something around there. I don't know. I haven't checked ever since I started adding this, but around 800. That's right. Am I tripping? I am tripping. It is supposed to be 64. Alright. So that's right. There you go. Okay, and then I'll put the goal cell right to the right of this one we're searching. So our goal cell needs to go down. Wait, where's our goal cell at this current moment? It needs to go down by 2. There you go. And then go back over here and then check if this is working. So the G cost should now be 64. For the age. So it's 90. Well, what's 60? Wait a minute, what I times it by? It's 128. Oh, we need to times it by 3. There you go. Okay, so the calculations are right. That's good. That's good. That's good. Now we can put this back to where it needs to go. The math is right. Which is good. Now, do that for everything. So we're going to check them to the left, and then we're going to check upward and then downward. So, right, left, oh, you know what? Right, left, up, down. Now we do that. Then come over here, go look at the open slots, and we have 4, and that's everything. Good. So that's what we need. There you go. And then now, what we're gonna do for node n in alg open flow lowest f is equal to a big number if node f is less than lowest f is equal to node dot f, and then int called lowest f I is equal to -1, and then just do this. Lowest f is equal to n dot f, and then lowest f I is equal to int I equal I less than alg open size plus, and then set that here, and then change this to alg, and then node called n is equal to alg open at I, and now we can say that, and then put a breakpoint here, and then what we'll do is we'll pick the lowest one, lowest fi n line, and then we'll do map change texture global get map from, and we want to do explored, which is 0, 1, 2, 3, which is the third one, at, and then what we'll do is we'll say node called new, or new n is equal to alg open at lowest fi, and then do new n dot x and new n dot y, and then false. So now the one we pick should turn red. There you go, so it chose that one. And then that's the lowest. And then is that actually the lowest? We're about to check. I thought I launched it. Okay. And then let's see. Open. The F is 207 here. 290. 207. So that's 207, and that's 207. These are both 207. Look like copies of each other. Oh wait, well this one is 128, 128. And then this one's always on. So where's the one at 128, 128? Oh, 64, 128, 064, 128. So these have the same one. And then what happens when they have the same one? I mean, I guess it doesn't even matter. And then what we would technically do is then we would say Pathfinding's. Oh, wait. Okay. And then what we need to do is once we pick it, we want to then do node or alg closed pushback new node. Oh wait, that's not saved yet. And then we want to do alg open dot pop. What's the thing too? Bro, this is so fresh. Just give me. Why would I do that? Just. How to remove a specific index in a vector C++. Thank you. So algorithm open dot erase alg open dot beginning plus lowest fi. There you go. So here we're pushing into the close and then removing that, and then there you go, and then save that there. So when I look at this, that element should be removed. There you go. And where am I? Oh, see. Wait, what? So now that should be removed, and it is not giving me that option to look at it, which is annoying. So then we remove it, so we add it to our close, then we remove it from that. And then our new, and then we'll have a, well, we'll do that at the bottom. And then if path alg path found return, because what I'm about to do is we're gonna say this. We're gonna say, oh wait, you know what? Int called cur step, let's put it 0. And then every time we run it, we say cur step. Oh wait, no, because that won't work. Just have it up here. And then max steps will just be like 5. we can do is for now, we're just gonna do pathfinding step, and our new node is and then it's gonna be this one. And let's just see what happens. It's not gonna work, but I just want to see what would happen. But we need to increment our steps before do that. Okay. It didn't really go anywhere. It's not a good sign. Still didn't go anywhere. Now why is it not going anywhere? So we're passing in this new thing, then we have to adjust it, right? Because we need, yeah. So we found the new node that we're at. So in our example here, let me just take a screenshot of this. No, not this. So we're here, okay? And then what it does is it'll either pick this one or this one. And then now when we're here, we need to check this one, then check that one, then check that one, and then check that one, right? So, what I should see happen is these should turn all red. And then we can continue and then just pick the last one. But we would have to, I have to add the checks to make sure not to pick any of the other ones, but, you know. But it's not doing that. It's like freezing. Pathfinding check here. Passing the open. Then we push back that into our close because we close it. I need to add those booleans close. So that collapse is equal to true. Or I'll just change this to closed. It's more unique. It's equal to true, and then when we step and we find a block, oh, we're never doing. Oh, it's getting stuck. I see what's happening. Okay. Because I never like actually do the check telling it. Right. Okay. So, first of all, I need to. Because it doesn't have any knowledge of this stuff, and it needs to have knowledge of that to not include it, right? Because what's happening is, I'm pretty sure, is it's going backward, and it's just re-adding everything, and it's just going backwards in time, and it's just stuck, and it's not going anywhere. Whereas, because we need to be able to grab cells out of here, and pick it out, but we're not. So that's why I need a tile thing. Because I need to store the tiles. So I could have a map and base it off like coordinates that you can plug in, and then you can just plug it in if it returns something. Then you know there's a cell that exists there, and if it doesn't, then you know it doesn't exist there. Or I can continue just this vector, and then every time we check, we have to loop through these vectors and see. And the only reason why I don't want to do that, because if it ever gets really, if it has to search really big, which it shouldn't ever, because it's not like we're making a maze, it would slow down a lot. But we just need to look up a specific element. So I think the smart thing to do is now get a map in here. So we'll include a map, and then this will be std map, which takes in a std pair of int as the key, and it stores nodes, and these will be called our sets, or I'll call our nodes. Or I'll just call our matrix so far. So what's going to happen here is we're now going to store everything in here, and this whole thing of this just existing is to just store information of stuff we already looked up, so we don't have to like loop through this. We can just go and point to it. Because my problem is if I just keep everything in the closed, then I mean I could. I feel like it'd be fast, like if I just loop over it linear like that. But the problem is I don't need to. I just need to look up one specific element. I don't actually need to search the whole array to do a calculation or anything. I just need to pick out one thing, right? There's no need to search. So I can just do that. See, if I just loop through it and check, it'd be so easy, and I don't have to add the map. Because I feel like right now I'm prematurely optimizing the algorithm, and I haven't even stress tested it, so I don't even know how slow it is yet. So is it really worth implementing this map real quick, or should I just do the 2 arrays and then just loop through that? That's my question. So I think I'm just overthinking it. Because this thing's not going to have to go far. The maps are going to be pretty small in this game, so given what we need, we don't actually need to do that. Because when I check if a tile is I go and grab it, yeah, I don't need to do that. I'm overcomplicating it. I'm prematurely optimizing. Let's just do what we're doing now. And then let's just have a function called, we'll put at the bottom, void get node, pass in and we need both our open, and then what am I doing? Close. And then we're gonna return a node first of all, and node called n, and we'll just return n right here. Just return this. And then have n right here. And then 4 times, we can just do 4 node n, basically in open, check if, oh, and then we have to do wait, what do I store these in? If n dot x is equal to x, and n dot y is equal to y. Return n. We don't need that. There you go. You okay? What warning are you giving me here? Stop. In our open vector, search that if n dot x is equal to x and n dot y is equal to y, return n. And then for node n enclosed, if n dot x, and then just do the exact same thing. Or we just return -1, right? I don't know why this is giving me issues. Potentially expensive copy of n. I guess, because I don't need to ever modify this. I just need to search through it. But I just want to just get the data, bro, and just return that. Why is that so hard? My end goal for tonight is to finish this algorithm. And I'm almost there. So I should be able to get it done within the 3 hours. I can get it done in an hour and 30 minutes probably. So, but I'm definitely gonna get it done tonight. I'm not gonna get off till I finish it. You know what? I don't care, bro. Go screw yourself. I don't care if it's expensive copy or not, bro. You can go suck it. So that's how you get a node, and then why was I doing that? I just went on this massive tangent and I forgot. Because now what I need to do is now that I can get a node, oh yeah, because I need to keep track if it's collapsed or something. And then I need to check goal. Oh wait, you know what? This is why we have flags. 0B for, okay, so we'll have collapsed. There you go. Oh wait, call it flags. Basically, we'll have 0B, it goes goal, start, end, or closed. So if it has one of those flags, so having a bunch of booleans, we'll just do that, and then what we'll have is, I'm sorry, dude. What are you mad at me for? What happened? Oh. There we go. Because we don't have to really worry about that for the regular ones, but flag, flags. Flags. And then we have flags. Then when we init our thingy here, what is happening when we init that? We never specify it, right? We never give it any other data besides that. So what we'll say is that, and then I just need to set, I don't really care about anything else, but I just need to set its flags equal to, right? And then I need to set this one's flags equal to this one. There you go. And then, now what we need to do is when we actually compare and check, we need to check the flags to see if it's actually worth it. So, checking if node is valid. So what we'll say is all we need to know, we don't, you know, because I'm going to run the check anyways, I might as well just add the booleans. Because I'm going to have to run the OR, and then I'm going to have to compare to see which one it is. So it doesn't even matter if I do this. So I guess let's just make it simple. I'm overcomplicating it. Stop overcomplicating it. Is goal, bool, is start. And then we'll just have bool, is collapse. I don't know how to spell that. There you go. Now instead of doing all that, just say is goal true, is start true. Because I would only do the flags if there's more conditions, but there isn't enough conditions for it to be worth it, and I don't want to do the mental gymnastics of everything. And everything, this will automatically equal false for everything. There you go. Whoa. There you go. Now we just check if, well, let's get the node. So let's see what happens. So n is actually going to equal, let's delete this. N is going to, or node called n is equal to equal to this. Okay, no. I'm saying. What do I need to pass in? I need to pass in the actual point which we're checking, which is b.pause x and b.pause.y. And I need to pass in our open, and then I need to pass in our close. Go. What's wrong with you? Oh, my bad. I put it in the wrong spot. Alright, 1 second. I am going to have to go to the bathroom. Alright. We're back. Keep going. Okay. Oh. Okay. Still fine. Well. So there we go, we get the node. And we check if node dot x is equal to -1. And if node dot is goal, then found goal. And then we'll printf found goal. I know what I need to do, but I'm not going to do it just yet. And else, if n dot is start, return. But what we're going to do is we're going to say that go and return. And then here we're going to say found start. And then else if n.x is equal to -1, return. And we can say, node already explored. Oh wait, if it does not equal, then we can return. So with that simple check-in, let's see what happens when we run it. Alright, we went out of bounds. That was expected. Well, I'm going to change the map depth to 2. Why did we search to the right or the left? Whatever, go again. Alright, so we also have to add the check to make sure that we don't go out of bounds of the map. So if we go out of bounds of the map, then we get an error. But right now, that shouldn't be a problem. Oh no, let's go. Why are you going downward, bro? Hey, what's your problem? Right, that's it. What am I printing out? Lowest F, lowest I? Okay, so we have 129, 256. Well, first of all, what is that? 256 divided by 64 is 4. 0, 1, 2, 3, 4. And then we have, oh wait, no, it's 129. Okay, well, it picked that one. I think 1, 0, or 1, 2, 3, 4. Let's start off here, right? Then it goes to 256. 92. I don't know what this thing's doing. This thing has a mind of its own, bro, and it's making me angry. 3. 1, 2, 3. So I should have picked this one, right? Okay, what is happening? I need to do this print shit stuff better. Alright, we're gonna remove all of this. Okay. So, here. This is the block we're looking at. Also, we need to check if block b.flags and what is 0b1? That will stop us from going out of bounds. Where on my blocks map? Block. It is. What did I write this down at? Let me just do it in player. Player. What's that check? It's 0b1, right? Oh, it's right here. Yeah, 0b1. So if this 0b1 equals 0b0, get out of there, dude. Not even worth it, because that means it's unable to be exploited. So maybe if I do it to 10 now, it won't break. But no, because we're still getting. But no, it shouldn't break. I think it's gonna break because I'm stupid and it's gonna break and it's gonna embarrass me. Yeah, okay. So this thing is going crazy. It is definitely going out of bounds. It's just this is so poorly written right now. Okay, what is it doing? I'm so close to deleting all this and restarting. The problem is, this is really spaghetti. Because the problem is, it's pointing here, pointing there, and it's going everywhere in this entire thing, and it's not synchronized at all. And it's just doing whatever it wants. And I can't keep track of it right now. Like, I have all these things I'm passing in, and like, Jesus Christ, bro. It's going over the map, it has to pull from the map. Okay, so here. The only time we pull from a subscript where it could actually result in an error, I'm gonna add this check in the map, is that this right here is if I is greater than m.pause.size. If it's greater than or equal to printf error reaching out of map, and this is in map underscore get block. Then return a block with negative coordinates. Just return 0, 0. And do the same thing here. If I is greater than or equal to m dash texture IDs size, printf error reaching out of texture index vector, and then so let's see what happens in that. Well, I need up the steps. Let's see what happens. Okay. 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 So it's not there. So where is this happening? so that's that checked. This should not happen, right? If we try to reach out, we're done for. And to prove that, I'm gonna just say this. Do this, but say like -1, -1, true or something. I don't know. Set this to just do it 2 times. Okay, so that's not the problem because we're getting that error when that happens. Reaching out a map, get blocked. There you go. Okay, so that is not the problem. So it's something happening. In our pathfinding. So when do we actually reach into something? So this is safe. Get node always returns something null if something goes bad. Right? Yeah. Turns negative. Oh well, maybe I need to say this is a node. Maybe. And then we push back. So we actually don't pull anything. Same thing for here. I wonder if it could be happening right here, but I don't think so. Wait, did I just do 10? No, I did 2. This is 2. Let's do 10. Let's see what happens in that. Yes, okay, so that's what was happening. Alright, there you go. So that's error check. Now that's error free now. Okay, good. Okay, so what the flippity flop is going on right now? So we're adding the check where, hey, okay, so first of all, this thing is picking something at random, you know what I'm saying? Every time we create a cell, I just want to print all the information about the cell. So I'm not going to print this out anymore. I'm going to do this. SCDC out. Let me just make a function that does it. X, Y, PX, PY, F, G, H, So first iteration we have the G's are 0, which is I think right. No. Well, what are the F's? So this is at 92, 92. Oh wait, no, 192. So this is the lowest. And now which one are we picking? Let's just run it one time. One time. Do it for the one time. Do it for the one time. Okay, so we do it one time. And we have this happen. Well, here. There we go. So, okay. I don't think that should be 0, but because here. And then let's print out our original. So we can just say current is 0, 0, so 192, 192. If you take, so our G, which is our distance from our start, is what formula? It is origin, so 192, minus, where's my calculator? This would be 192 minus, position do we pass in? Yeah. So it'll be 192 minus 256, which is 64, right? And then that gets turned into and that gets squared, right? And that would be squared root of 64, correct? And then you do origin y, which would be 92 minus 92, right? So how is that equaling 0? That shouldn't equal 0. Square root of a squared plus b squared. That shouldn't equal 0. Negative 64, 0. That makes sense. So how flippity flop? Are you getting 0 for the G? That shouldn't be happening. The G should not be 0. The G... Wait, what? Oh, I think I just messed something up in my print statement. I did. Oh, I was just debugging an issue that wasn't even a thing. Oopsie. My bad. Well, that was a waste of time. It's okay. I just wasted probably 15 minutes. It's okay. It's okay. I'm fine. There you go. So then we pick the lowest one, which would be that one, right? And then what we should do is hop over to the next one. So what I'm gonna do is do max amount of steps equal to 1, and then what we're gonna do is do that one. Wait, let's say print, and then we'll do std cout new cur. Oh wait. It does that at the start. It doesn't matter. Let's do let's just do that. So now try it, but we'll do one more step. And then it chooses the wrong one again, but whatever. Oh wait, because it shows a different one. Okay, so now we were supposed to be. We picked this one, which is 192, 192. Well, what is 192 divided by 64? That is 3. So 0, 1, 2, 3. Wait, 1, 2, 3. What? Wait. Yeah. 0, 1, 2, 3. So 0, 1, 2, 3. And then 0, 1. Oh, wait. Then 1, 2, 3. Wait. 0, 64, 128. 192. We chose our starting cell. Why did we do that? Oh wait, I'm looking at the wrong parent cell. Alright, so yeah. So 3, and then we chose this one. And then we go here, and then we're supposed to explore this one and this one and this one and this one, right? But then it says node already explored. Well, this one isn't added. These two are added, so why is it saying that? And then we're running through and we're picking this one, right? Okay, so why is it not adding those? What's happening? We're doing... Oh! Dude. Oh my god, bro. There's no way. Okay, so I'm gonna explain. Bro. What? Wait. No, there's no way. Dude. Okay, so I'm gonna explain what is happening here. The way this works, okay? The way this works. Okay, so the whole reason why I've been having this problem for the last probably like 45 minutes, and this is gonna be amazing. I'm so excited to show you. I've sat here and done nothing for the last 45 minutes because of this one thing, and it's because I misspelled one thing. The way this algorithm works is we have our grid, right? And we start here. Alright, let me build a bigger grid. There you go. So we start here. Then we look this way, this way, this way, and this way. Then you pick the one with the lowest F cost. And then you go here. And then you do the same thing. Look this way, this way, this way. But the problem is the reason why it doesn't change ever is because for this whole time, I've been only passing in the starting cell. I've never actually passed in our current cell. So it's never been moving. It's been stuck. That's why it's been changing. That's why it's been going the wrong way. That's why it hasn't been. It was going out of range because it was just starting. What it would do. Oh wait, I don't know what's gonna happen here now that I did that. But what's been happening is. Come on, load, buddy. What just happened? I think I glitched out. What's my max steps? 1, 0. Here. Don't do that anymore. Just do it one time. Maybe there's an issue because I'll keep explaining in a second. One second. Okay. So what's been happening is it's supposed to go and now check this spot and look this way and this way and this way and this way, right? But since I never told it that it needs to go there, right? Because what I was gonna do is you pass in this current thing, and then you pass that into here because that's your starting cell. But I was just always forever passing in the original starting point, so it was never moving, and that's why it would look this way, and then just stay here, delete this one, and then check this one, and this one, and this one, and then go out of range and then blow up. So yeah, that's why that was happening all that time. So that and that's all because that's pretty crazy. So. That was a good 45 minutes, probably an hour wasted that because it was just that one thing. But now I gotta figure out why it's like freezing. So now I gotta actually figure out why it's freezing. So we have the new one, and then we want to check this way. So we're gonna do it one time. Oh wait. Because we're at 0, yeah, so greater than, if we go greater than max steps, yeah, okay. So yeah, that was a good hour wasted for nothing, but it's okay. Now let's figure out why, oh, there we go. So it went here, and then it's gonna find the goal. There you go, it's finally moving, yay! And then if I were to do one more step, it should actually like change the goal cell to red probably. Oh wait, no, it wouldn't. It would just return. We should get printed out that it says found goal or something. Oh, it did cover it. And then I don't know if you're able to see it. I gotta fix it. But it eventually reached where we need to go. But now we need to. So there you go. It's right. Hopefully. Now I just need to actually implement everything. And I sat here for the last hour trying to fix that, and it was just one thing messed up. It was not even the. It's not even the algorithm, it's just me, but whatever. It's okay. It's okay. Alright, now we can go back to what we were doing. So if we found the goal, we want to print it out, right? So if the node we grab, oh yeah, because we're changing the texture before we do that. I don't want to change the texture. I want to change the texture after. And then we want to make sure that it is, make sure it's not walkable. If it does not equal that, and then we can just say, oh wait, well, we're changing it. Nah, wait. I don't remember. Alright, let's see what happens. Oh wait, god damn it, I never put that back in. Already explored, already explored. It just does not seem to register that it's finding the goal cell or even the start cell. Which is odd. And it's not even registering if it's actually blocked either. So that's a problem with my grabbing function. When we init, we set it. These are true, correct? Yes. We set start equal to start, and then we tell start that is true. So, what are you doing, bro? We should definitely see this, especially when we step one time. Oh. Oops. That's why it's not happening. Oops. Just add, that's why that's happening. I understand. We're good. Add push, close dot push back. Add goal. Add close dot push back. Starts. Now, that shouldn't be happening. I understand now. And that's because it wasn't searching for it, like, cause it's not in that array. And there you go. Found goal. Boom. Wait, will it tell me it found start? There you go. There you go. There you go. Let's make its own texture. How about that? Let's be nice. Let's be nice to the start or the goal one. It needs a nice yellow texture. That's cute. That would be cute for him. Save a JPEG, and this will be goal. Now go into our load order. Goal, and that is 5. So when we init it, the goal cell gets a 5 because it's pretty. And then the start cell will be 4. There you go. Now we should clearly see it. There you go. And you need to stop exploring out that way though, which I will get to in a bit. So now that that's in the loop, let's go down here and delete this check, because I don't need to do that anymore. Now that should be cleaner. And that's max 2 steps, which is doing a lot for 2 steps. Wait, no, it's not. I don't know how it should, oh wait, yeah, because, I don't know. Oh wait, you know what? I'm doing this math equation wrong. There you go. And we're almost done. We're almost done. We're almost done. We're about to be there. Now I just need to add the conditions for when we do find the goal cell. And then I need to just trace back and then draw the actual path, and then we're done. Found start. And then we would need to run it one more time to find the goal, because we're right here. There you go. You can see how it kind of thinks. If I put the player back more and try to search, and then I'll do it 3 times this time, it will see, it goes in the right direction. So smart. Thank you. I'm happy. I'm happy it's so smart. But we're not done yet. It's going in the right direction. Now we need to actually figure out what to do when we find the goal cell. So give me this 3. Okay, so actually I need this to stop happening. Git map. We're getting this block, and then we need check. We need state its flags, okay? Because it is getting looked at, and I don't want those to be looked at. So block flags, and then print b.flags, and then put x. All I need. There we go. Okay, we're gonna put on every time I put on this, I get screwed over, but I should be okay. Where's my timer? I can't see my timer. Oh my god, my day's ruined. That's not cool. Block flags 1, block flags 1, block flags 1, block 1. 0, 0, 0. So don't search it, you stupid idiot. So print the result of me doing this. Print that result. Tell me what happens. Oh, wait, you know what might have been happening? Maybe. 1110. That's the bad one. What's 320 divided by 64? Oh my god, calculator. 5. 0, 1, 2, 3, 4, 5. There you go. Found it. So if that's the case, I just see a block statement, and then we return, and we leave. Do you understand me? You're not doing it for me. What are you doing, you idiot? You see it's 0. Bro, what are you doing, bro? What is this flag system? Why is that not working? Okay, 1 second. And flag check is equal to B. What is your problem? Oh. Oopsie. Oopsie. Oopsie, oopsie, oopsie. I was using the wrong sign the whole time. Where am I? There you go. And now I need to go into my player and fix that. So many good things are coming out today. Now let's hope that didn't break my whole collision system. I'll be very sad if that happened. Didn't. Here's the problem. Here's the problem. You're still doing what I don't want you to do, bruh. What is this? Correct order of operations. There you go. And that needs to be 0B0. Yes, oh my god, thank god. Idiot. I need to go to my player. Fix that. There you go. There you go. What's your problem? That is the correct order of operations. Leave me alone, you freak. Okay. I'll just do it here. There you go, now my flag system's in place. And that actually works. That's knowledge learned. 30 minutes till we hit the 3-hour mark, and I still have yet to implement this. I'm almost done though. I'm a failure. No, I'm not. That's a bad attitude. Okay, now let's hope my collision system doesn't break. Didn't break. Yeah. Now it doesn't search that anymore, so that error is fixed. That I needed to fix eventually, and I can stop printing this out. There you go. Now, once we found the goal, we immediately So now we're at the point where we found the goal. Right. And once we find the goal, we don't want to run this again. So I'm just going to say current step is equal to max steps. Plus 1. Right. So that should stop it once we find the goal cell. It didn't. Oh wait, you know what? We don't want to do that. And let's have in our A-star algorithm. Called path found. Honestly, dude, at this point, let's just pass the algorithm itself. There's no point just doing all this stuff. We have that stuff comes from the algorithm anyways. Just passing the algorithm. Stop doing this. Passing that pointer, baby. There you go. Now, you can stop complaining. So now, I'm just gonna delete all this. Pathfinding, check direction, pass in our alg, pass in map. We don't even need to pass in the map anymore because the algorithm has it. We can delete that too. All we gotta pass in is the alg, where we want to go, and then this, and so we want to check to the right. To the left. Up, down. Up is that way, down is this way. Now, go back here. And then say, now here we can just say alg map. And that's simplified. Here we can say alg open, alg close, alg goal, alg. Keep going, alg, boom. There you go. Now let's see what happens. So that was a little nice cleanup that I had to do. Eventually, still works. Now once we found. And then if alg path found, we're gonna return, but then we're gonna call trace function. So if we found the goal, alg path found is equal to true. And then alg goal dot parent x is equal to origin dot x, and then alg goal dot parent dot y is equal to origin dot y. So we shouldn't, once we hit the goal, we should stop searching. There you go. And to prove that worked, we're gonna do this. Boop. Beep. We're gonna go into the corner, set the max steps to like 10, and we should find it. And we did. Boom, A star, done, easy, less than 3 hours too. Less than 3 hours, A star is done, but now I actually need to implement it so it traces the path back. Because if I were to put a wall right here, and now let's see if it'll figure out how to get around the wall. It does figure out how to get around the wall. Let's go. Let's go. What if I do something like that? Let's see what it does. There you go. A star is done. Thank God. Look at that. That's beautiful. I'm so happy. I'm a happy guy now. What if I like do this? There you go, it figures it out. But, you know, it has to, you know, trace back. Now we can call the trace back, which is always amazing. So for the trace back, I'm just gonna want to return like a vector of like positions basically, but for now the trace back is just going to void called Pathfinding trace back. Is trace back one word? It is one word. And then just pass in our goal. And then come in here and we'll just go node called n equal to get node. Just passing the algorithm. Node is going to be equal to alg. Wait, what are the arguments? Alg dot Thanks for the party, the emojis. Thanks. Okay, what do I need to do? You map. Texture ID. Let's do the path one. That's the fourth one. 4. N.x and N.y. False. Alright, let's see. And then now, once that happens, alg or pathfinding trace back. Dereference that, and it should trace back. Hopefully, not die on me. Please don't die on me. Oh wait, it's not gonna work. Yeah, because I never. And then n is equal to n is equal to get node of n dot parent x and n dot parent y. And then this is the same thing. Now it should work. There you go. Now, start pathfinding's done. There you go. Now let's experiment with it. Let's make the map 10. So let's go down. Oh. Yeah, bro, W, that's what I'm saying, right? Watch this shit. Oh, sorry, I'm cursing now. I got too comfortable. Watch this. Watch this. Watch how smart it is. Now let's say, I hope I don't. Boom, look how smart that thing is. So smart. Third time I ever made this thing. Oops. Oh, I think it ran out of steps. here you go. You get 100 steps. Yeah, there you go. There you go. A-star pathfinding's done. Now I just need to implement it to be like actually adjust on the fly. Let's make it like a little maze for it to find. See, some people might think we're going in there, but if you go in there, you're stupid. We're actually supposed to go in there. And then the player can get shoved into here, and then I guess this has to be cleared out then. But yeah, and then blocked here. This will be the test if it's smart enough to get through. There you go. So smart. And then since the goal is at the top right, I can just say close that, open this, open that, close that, and then that goes open, and then there you go. And what they say? And they said I couldn't do it. And they said I couldn't do it. You know what I'm saying? And they said I couldn't do it. Take that. Oh, I glitched out of the map. And look at that. It doesn't even crash. It doesn't even crash when I go out of the map because I'm that smart. I'm that smart. It doesn't even crash. Look at that. It doesn't even crash. But I need to glitch back into the map. There we go. I'm back. Look at that. So smart. My baby. Oh, I'm so happy. Alright. Oh, Jesus. Okay. I think maybe I implement like trace back. Here. Now what I can do. So I see how it works, right? Let's see. Man, you should listen, Andres Benitez Jaimez. You should have been there for the whole stream, okay? You would have saw magic happen. You would have been amazed, but no, you weren't. It's okay. It's okay. I'm not angry. Alright, and then we can get rid of this painting thing. That does not need to be here anymore. And run it again. Yeah. There you go. And then what I can do... Bro, you did not work. I'm gonna expose you, bro. You were not working from 10 a.m. You did not work a 12-hour shift. That's all I'm gonna say. Yeah, Womp was right. You didn't even work at 12. You didn't. What time did you go to work today? Damn. I'm gonna change the title. Oh, you work 12 to 10? Bro, you guys are so crazy, bro. Spamming all those emojis, bro. Thanks for the love. Thanks for the love. Yeah, thanks for the love. What the? Wait, watch this. Watch this. Oh, crap. Oh no. Oh no. Oh no. Oh no. Oh no. I'm restarting. 1 second. Yo, you guys are crazy, bro. Stop spamming all the emojis, bro. Thanks for the love, bro. Thanks for the love, bro. You guys are crazy. Oh my god. I'm so good. I'm so good. Did you see that? Hey, whoever that kid is. Hey. Yeah, did you see that? What? What? Alright. 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 Alright, it's okay. It's okay, buddy. It's okay. It's okay. It's okay. It's okay. It's okay. It's okay. Face reveal at a million subs. Face reveal at a million subs. Face reveal at a million subs. Just wait till I get a million subs, then I'll face reveal. Or what are you talking about? What are you talking about? What are you talking about? What the? What is happening? I'll do a giveaway at a million subs. So subscribe and like. $100 subs, MacBook Pro giveaway. 100 subs. So make sure you drop a. I need to do the opposite of what's happening here. Alright, you're being a fangirl, you're being creepy. Just happened. Did my thing just go down? No, it didn't. Why don't everything clear? Oh yeah. Spam emojis so you can hear me. Spam emojis if you can hear me. I need my chat rate up. Spam emojis if you can hear me. Yeah, that's right. That's right. Thanks for the love, guys. Thanks for the love. The love. I finally feel like a real streamer. I feel like, whoa. You're banned. Whoever said that, you're banned. RHIAN, you're banned. Banned. 5 minutes ban. Banned. Yeah. You're banned. Yo, what are you being inappropriate? Is worm what I think it means? I'm only 36. I don't know what you're saying. So, is worm what I think it means? Because if it is, I don't want to be hearing that. I'm too young. Bird. That is. I don't know. Oh. I don't have a bird. I don't know what you're talking about. You're weird. Get away from me, freak. Oh, sorry. I didn't see. I love my audience. I love my audience. Okay. I would never call them freaks. He is sleeping. You can't hear him. Jesus. That's right. Spam emojis. Spam emojis if you love the chat. If you love the chat, spam emojis. Yeah, thanks for the love, guys. Thanks for the love. You guys are awesome. Yeah. Jesus. Things I do for money. I want some hey, if you throw a donation, $100 donation, I'll give a MacBook. I'm gonna give a MacBook away for free. $100 donation. You're banned for asking if I'm gonna get off anytime soon. You're banned. You're banned. You're banned. You're banned. I actually don't know. I don't even know if you can donate to me. You're banned though. But you're banned, so it doesn't even matter. You can't even donate if you're banned. Bro, my chat, you guys are so crazy, bro. You guys are so crazy. Thanks for the love, bro. I never thought my dream of being a streamer would become true. Yeah, bro, I keep seeing the emoji. Yeah, celebration. You guys are so awesome. Woo. You guys are awesome, bro. Thanks for the love. 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 Patreon. If you're about to threaten to dox me, you're getting banned. You're banned. I don't play around. I'm only 35, so I don't like this negativity. You're banned. Yo, Andres Benitez Jaimez, bro. Spam some emojis in the chat if you want her banned. Whoever spams more emojis gets banned, or whoever. Alright, you're threatening me. Andres Benitez Jaimez, spam emojis so I ban this, so I ban her. Yeah, I am actually a major streamer. Thank you very much. Thank you. You know, this really was my passion since I was at a young age. This was my passion since I was at a very young age. You're banned. How do I ban someone? Alright, you're getting banned. Oh, wait, I'm gonna put you in timeout. Oh! You're banned! You're banned! Don't come back, you're banned. Alright, wait, Andres Benitez Jaime, should I unban her? Oh, someone's calling me, guys, 1 second. Hello? How do I do that? How do I remove someone out of timeout? Yeah. Oh, crap. Toggle moderator activity. What did that do? I don't know what that just did. Crap. Oh no. So hey, someone look up how to untime out people, please. Oops. How do I do this? Hey, Andres, I need you to help me figure this out. Oh, whatever. Here we go. Oh, well, why am I just put C++? YouTube live. Oh, sorry. Whoever I put in. Oh yeah, I put you in timeout. You're stuck. I'm sorry. You're done. You're done. You're stuck in timeout unless Andres can save you. If Andres can save you, you're done. You're chilling. But until then, I'm sorry. You know, it's a hard life out there. You know, some people. I'm sorry for whoever. I'm sorry I put you in timeout. You know, maybe down the line, you know, you'll learn from your mistakes. Okay, we're done here. Alright. Now, last step is I just gotta return this vector of positions, but right now it goes from goal to start with its positions, right? and I want to return start to goal, right, when I return the positions. So what we need to do is we just need to flip them. So what I'm going to do is, like, say this is 100, 90, 70, 30. What I'm going to do is I'm going to have a pointer here and a pointer here, and then we'll swap those two values in the first iteration. So 30, 100, 90, 30, and then increment. This will be decremented or decremented, and then this will be incremented, and then we swap, and then we're done. 2 pointers. So while j is greater than I, path at I is equal int called temp is equal to path at I path. Oh. Yo, they're back. Alright, hopefully you learned your lesson. You know, I like being nice to my viewers, and, you know, I'm not a bad guy, so, you know, hopefully you learned your lesson. Yeah, I don't play games, by the way, so, don't mess with me. Don't mess with me. I don't play games. I don't play games, so I'll ban you. You'll be banned at any second. Okay, so we can see that this worked from right here. 256. Whoa, 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 whoa. I just got a message held for review. You said shut up, kid. So, I don't know if you know the rules of this chat room, but you gotta be super, no, you gotta be super respectful, so, you know, I'm gonna have to ban you again. So sorry. Yo, Andre, spam emojis in the chat. Spam emojis in the chat if you want her banned. And then after this happens, it should be flipped. Oh, it's gonna... Oh, look at that. Look at that flipping. There you go. Now that's the correct path. How amazing. Whoa, whoa. Whoa, 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 whoa. Guys. Spamming is not the way to go in life. I think I'm gonna have to put it on slow mode. You know, I have too many followers happening right now. I got too many followers, so, you know. So 0 is, yeah. Alright, there you go. Alright, so basically what I just did is now I finished up the algorithm. So now it will return the path, so I could just follow this along right here, and then it will, you know, be calculated correctly. So I can remove this. This does not need to happen anymore. And this does not need to happen anymore. There we go. So that is A-star fully coded up. Everything's done. Oh, I need to get rid of that coloring. And then it'll be done. And then we don't have to worry about A-star anymore. And then I gotta remove all this printing. That was also, you know, also considering how I have everything structured in the textures, it was pretty nice that it's pretty efficient how I have everything set up. So where I could just like print, like just switch the textures instead of having to create blocks and render it. Like, that would have been annoying. All right, so where am I doing this? Map, change texture, delete. Actually, I should just comment that out because I ever need it. Actually, I should go back and replace those and just comment those out. Whoa. That's all testing stuff. Alright. So map, change texture. Go down. Oh my god. Next one. Next one. Next one. Is that it? Yeah, okay. Face reveal at 2.5 million subscribers and 332. That's when face reveal happens. And then if someone donates $100, MacBook Pro giveaway. So $100 for $2,000. That's a good trade. Yo, spamming. I think I'm gonna have to put my foot down on the spamming. It's going a little crazy. I don't think we want this to happen anymore. The spamming has become a problem. Bro. Where is my thing I need? I'll just go look. On my laptop. See, if the spamming gets out of hand, I will have to use my power, and I don't want to do that, but if it does happen, you know, I will be forced to, you know, actually put some rules in here. You know, I don't really want to do that. I don't want to be the bad guy. But if I have to do it, I'll do it. You know, my stream is supposed to be a happy place. My stream is supposed to be a happy place. And you guys are not allowing my stream to be a happy place. You guys are actually kind of corrupting it, and I do not like it. You understand me? Alright, so right now we're gonna clean everything up, and because A-Star is actually done, so that's amazing, and let's just clean everything up. And then we're good to go. Log. This node print doesn't need to happen anymore. How do I like tell it to actually do that? Do that. Replace it, dude. There you go. Good boy. I don't like what you guys are doing in the chat right now. It's kind of being inappropriate, and I think I'm gonna have to enforce some rules. What are you saying? What are you saying, dude? You don't need to say that. I don't. No, you don't need to say that. Oh, okay. Honey is coming home in like 2 seconds. Just give him a minute. Hey, Andres Benitez Jaimes, if you're still in the chat, bro, spam some emojis. Give me some love. Let's spread some love. Let's spread some love. Let's spread some love. Oh. Oh, did he say that? He has homework. He has homework for his intro to college algebra class. Oh, that's sad. You got me distracted. You got me distracted from my mission. I am hurrying. Give me a second. I'm almost done. You have to have patience. You're getting impatient. Patience is key. Alright. I think that's all of the debug stuff cleared up now. Now it's, oh yeah, and then just now we should be able to just go into here and turn this off, then nothing should be printed out. That got printed out, which is alright. So I'm just gonna clean this up real quick and then I'm gonna be done. So let me just close all this stuff that doesn't matter. So this looks all good. This is good. This is good. This is cleaned up. This is cleaned up. I can delete this comment. That doesn't need to be there anymore. Okay. Alright, so yeah, that's a story done. Thank God that's over. We can finally put that over to there and give our monster A-star pathfinding. Actually, no, we can't. We have to, I have to just implement this now. And then what we can say... We don't really need to call the trace back. Actually, here. I'm thinking we do that, and then it's up to the user. And then if alg dot path found log path not found returning, and then return, or just return empty vector. Just return this. There you go. And then now what we do is, for now, we'll go here. And then we'll have st vector of C. Okay. I need to add some stuff. Add better debug tools. And then now for the monster, that's done, but we need to do, actually no, it's not done. We need to do for A star, make it so monster will follow the cells provided. And by us doing that, what I'm going to do is go one by one. What I did is I just want the player to actually do that. So we're gonna then every frame I don't know. I probably should do that tomorrow. I'm gonna do that tomorrow. So we're done here. So the next thing to do is to getting monster to follow path. There you go. Oh wow. Following. Oh my god, I just A stuff. Entities following A star. And that will be on the next day. So, let's stop the work timer. It's over. We're done here. So, today was pretty successful. We implemented A-star pathfinding fully. There's no errors. There's none, from what I've seen. There's no errors. There's no nothing. We're good. I'm pretty happy with how it turned out. It's well written. I think personally, it's well written. It was easy to debug and everything. And if there's ever errors, I have solutions already set in there to debug. Yeah, so tomorrow or whenever I stream next, we're gonna work on getting the AI to actually, like, something to actually follow
the A star, because right now we have the path, and now we just need to implement like actual physics or like a brain to guide the monster to follow that path, and then that would be the next step, is getting it to follow the path realistically and how we want it to do it. But for now, A star's done. The whole algorithm's done. Now it's just up for us to actually implement it into the game and into our AI. So today was a very successful stream. It took me, even though I did spend like 50 minutes on like a glitch that was just one word. It was just I swapped two words, so that was the problem. We were able to code a base star in one session in 2 hours, in like 2 hours and 30 minutes, or 2 hours and 10 minutes or something. So that's good. Normally, last times I've programmed it, it took me quite a little bit. It took me a couple days, but I think it took me a couple days maybe. I don't know, but we did it in 2 hours. That's amazing. I'll never be able to do that. And I have implemented it way better, and as we go on, we can make adjustments to it. Where like I don't know if doing this traceback thing's the best idea for the nodes, but right now it's gonna work, I think. So we're good. Tomorrow we'll work on actually getting the monster to follow, and then we'll work on some more debug tools, and then we'll start planning out. I guess right so far now, I mean, it's just really getting this. I mean, this was like the hardest part. I mean, now we just gotta get the AI to like act normal. We're gonna work more on the AI. We're gonna do AI research next time, and get that all good. So figure that out next time and get the actual thing. Maybe make movement feel more fluid. Add like different things, but I feel like that's later down the line. But because right now all I want is just a really solid basis for the AI and the monsters. That's like the main gameplay loop. Everything else is secondary, so it doesn't really matter. But yeah, so with A star done, that should conclude our stream, and very successful stream. Thank you for everyone who did show up and watched. And most definitely gonna be live tomorrow because I'm on that grind. I'm trying to get this done, so So yeah, thanks for everyone who showed up, and thank you for